Hello friends, welcome back to my channel. So in this video we will see the distribution function and density function of a random process. In the last class we have seen what is a random process and its classification, and what is a deterministic random process and non-deterministic random process. In this we will see how to define the distribution function and density function, and they are very useful in defining the stationarity of a random process. So random process, we can define it is a collection of random variables indexed by time t. Examples are noise in a communication channel and stock prices over time and heart rate signal measurements. Now coming to the definition of the distribution function of a random process. So this is how it is defined. The distribution of a random process is the joint cumulative distribution function, because we are having the random variables at different instant of time. So that is why it is defined as joint cumulative distribution of the random variables that are observed at n different time instants So for a random variable we have defined fx of x is simply probability of x. The random variable is taking values less than or equal to small x. So here random process means it is included or indexed by the time instant. So that is why we are denoting the random process as x of t. So if we are taking at n different time instants, so that is nothing but n dimensional distribution function. So fx of x1 comma x2 and so on xn, these are observed at t1 t2 and so on tn. Now the random variable is indexed by time t, so that is why we are including the time index also. So earlier we have probability of x less than or equal to x. Here we are observing the random variables at n different time instants. So probability of x of t1 less than or equal to x1 taking values less than small x1, and x of t2 at time instant t2 taking values less than or equal to x2, and so on x of tn less than or equal to xn. We will see with an example. Suppose x of t represents noise voltage at the receiver at two time instants t1 comma t2. We can write it as fx of x1 comma x2 comma t1 comma t2, as we are having two different time instants t1 comma t2. So that is given by probability. Sorry, this is probability of x of t1 less than or equal to small x1 and x of t2 less than or equal to x2. This is the how we define the distribution function. Now we'll see how we define the density function of a random process. So as we know, for a random variable, the density function fx of x is given by d by dx, derivative of the distribution function. So in the same way, so if the random process is continuous valued, so if we differentiate the distribution function, differentiate the distribution function, we will get the probability density function of the random process. So it is denoted with similar to the distribution function, small fx of x1 comma x2 and so on xn at n different time instants t1 comma t2 and so on tn. So we have to differentiate this with respect to x1, with respect to x2 and with respect to xn, the joint cumulative distribution function. So similarly, if you observe at two time instants t1 comma t2, So it is simply dou square by dou x1 into dou x2 fx of x1 comma x2 comma t1 comma t2. So here dou is the partial derivative. In summary, random process is a collection of random variables indexed by time. So what is distribution function? Probability that the process values are below a certain threshold with respect to the given time instance t1 comma t2 and so on. Density function we can get from the distribution function by taking the derivative of the distribution function. It gives probability value. It gives the probability value per unit value. So these are the definitions of the density function and distribution function of a random process. So for two variable case, so this is how we define the density function, and similarly this is how we define the distribution function of the random process. So these are very useful while defining the stationarity of a random process. So I hope you have understood what is the distribution function and density function of a random process. So thank you for watching. Please subscribe to my channel and share with your friends and in your friends group. Thank you.